the very important part of this course, which is the last or the final, which is known as Bytecode in Python. So without wasting much of our time, we are going to dive into that. So we are going to have basic understanding of Bytecode interpreter. So actually this simply means, I think that should be tax 19, so 13. So this simply means giving out our code in a more readable format. So we know that we compile our code and we're having a bunch of 0110, but in this way it's something that is readable, so something like that looks just like this, something in this format. So it's a bit code. So this is a bit code. Actually we'll have it in more this thing. So let me change how it looks. So see how it's gonna look with the full width of it if it's on a desktop mode. You can see it here. So you can see what we are having here. So just like this. So just wait for it to load. So I'm going to scroll to where we are, so get a glance of it. Then I'm going to explain some parts of that to us, so we know what Bytecode is all about. Okay. So with a Bytecode is more of in an English language, so something that is more communicatable. So write a Python function def magic calculation. That's a function, the name of the function, that does exactly the same as the following Python code. So this place here is always on its own. That's just the first part of it. It's trying to tell us that it's a 3-line code or a 3-line file. So we have 3 lines here. Then that's for this part that we have here. So it's always in 3 line. Now after that we have load constant. So whenever you see it, it means it is a hard coded constant. So we just drop it like that, 98. It is not passed through any this thing. So the value of this load constant is 98, that it cannot be changed like that. If we drop 98, except you go back to the code and make changes to it before you can make you can switch the value. So they put it load constant. So load, when you say load constant, it means that you can't change it. It's a constant number. 98, 98 is a constant number. Then we have another one known as load fast. So load fast is a variable. Why they call it load fast? Because it's very fast in loading. It functions preferable or more than any other this thing. So because it is the first one there, we have 0, which is A. Then we have another one, load fast 2, which is B. So this is another global variable. So you can call them global variables. Yeah, they load very fast. So that's that. Then inside our code too, we have the first thing that comes in place is binary power. We don't need to talk about, but when you say power, it means anything raised to the power. So you can say 1 raised to the power of 2, 6 raised to the power of 4, and so forth, like that. So that's for the binary power. Then we have binary add, which is also part of this. So under the binary add, we are going to be adding something. So these are the things we are using. We are using power symbol in our code, and we are also using add symbol, and after that we are going to return our value of whatever we have calculated. Whatever we have calculated is going to be returned to the screen, and we're going to check this. So actually there might be a slight difference based on the numbers we have here. These 3, 6, 9, 10, and 11, there are going to be a slight difference, but it's fine. Your own might not be in intervals of 3 or 2 or whatsoever, so that's where there is going to be a difference there. So without wasting much time, we are going to go ahead to walk through some stuff there and see what we got. Okay, so let's get started. So we are creating a file called 10magic calculation.py. So I'm just going to copy that because that's one of the files we are going to be creating, and it's going to be inside a directory 0x0 python hello world. So so all of this should be math, which is part of our Bytecode. So I'm just going to go to my terminal and see what we can do there. So this is my terminal here. So I'm just going to clear the screen. Then we are going to navigate to our usual place. Sorry. CD. Okay. CD. The next one is this one. So we are in here. So I'm going to list what we have here. Okay, so these are the projects we have done previously. So now we are about to embark in a new one, which we are creating now. So I'm just going to clear what we have there, and I'm going to make a file. So I'm going to paste the name of that file I have copied. Good. And this is the file I have copied. So now that I have created this and I have copied that, I've copied that. Now I can go ahead and start typing the function that is going to give us that. So for us to be able to view our file in that format that you see there, we need to import a module to do that for us, that's going to convert our file to a bit code, so which is very important. So I'm going to start with hash, then exclamation mark, then slash usr, then slash we have bin and pyth and g, then that is it for that one. I'll go over to the next line. So this line here is going to be our function, our function is going to be here. So what's going to be the name of the function? To call the function df, then the name of the function, the name of the function is magic calculation, if I'm not mistaken, magic calculation. So the name of the function is magic underscore calculation, like that. I'm coming calculation, just like that. Then open and close parenthesis. Inside this open and close parenthesis is all receive two parameters, which is a and b. So those are the two things the function is going to receive and is going to do the calculation, and that is fine. So now you see we have an indentation. So at this third line, because this is the first, second, and this is the third line, at this third line we are going to be returning our final answer. So our answer is going to be, now when you look at the bit code closely, you see we have 98, which comes first. So I'm going to put 98 there, 98 there. Then I'm still going to look what we have there. We have A and B, so I'm gonna put A, B there. So I've put those three stuff we have there. Then the next thing is I'm going to put the stuff we have there, which is binary power. So based on the binary power, I'll come in between here, and I'm going to add this sign. This sign simply means raised to the power. So let me create a space here so you can see that, raised to the power. So I'm just going to put this in a separate brackets. So this is a raised to the power of b for the first one. Then for the last one there, we are going to add it with the constant, which is 98. So this 98 is the constant, while this is the fast constant, fast what, load fast. Our order is load constant. So just like this. So we can go ahead and run this function, and you see what we have there. So if we go and test the function, let me copy this. Now let me tell you, a module can be anything. A module can be file, a module can be a function, a module can be a variable, a module can be something that you can move from one place. So modules are those things from a file you get. So for instance, I'm going to paste that because I want to test the function. So I'll come over here, I'll put 2, then I'll come here and I'll put let me put 3. Well, let me just put 2 and see what we get here. So 2 raised to the power of 2 is 4, then 4 plus 98, so something like that. So I'm going to go ahead and change the mode. Like this. Then I'm going to do 1 0 1 0 2. Then I'll check what we have there. So we have it here, so everybody can see that. Now the next thing we are going to do is I'll clear the screen. Now I will try to run it ./102 like that. Okay, so it's returning, but actually we don't know, we can't see what is returning because we didn't print the file out. Okay, so let me try something to see. I don't know if this works. Okay. We have 0, that is an exit this thing. But actually, whenever this is run, because it is a return value, something is being returned on the screen. So except we print this out, so that's when we can have a very tangible value we can work with on when it's involved the terminal. So I'm going to get rid of this. So this is what we have here. Now I want to see if our Bytecode goes the same way. So what I'm going to do is, if this is our code, I'm going to import what is called dis, just like this. So import this, and this is a module, so I'm going to make use of that module. So I just say this dot this, then inside it the name of the function, I'm going to copy that, then I'm going to paste that there, and I think that is it. So I'm going to escape, and we are going to execute this to see what our outcome is. So like this, so you can see what we have as our outcome. So let me try to let me execute it again. Good. So you can see we have 3, sorry, not that, we have 3 here, which is the number of lines, 3 lines. We have 1 0 1 here, 98 A and B. Then here we have this place that is 6. We have binary power, we have binary add, and we have a return value. The only thing that changes here is the numbers we have at this back place, all these numbers, which is 0 to 4 6 8 and 10. That's the only thing that changed there. I think maybe because of the version of Python, or I don't know, actually something related to that. So with this is fine. So you can learn how to read this, know what each of these. You can go ahead and make your own research, which is just fine. So I hope you guys enjoyed this. Please don't forget to subscribe and like my channel, and if you have any issue, please drop it on the comment section. So for the graphics, someone make mention of the graphics, so you can go to the settings, then look for advanced option there, then you can increase the graphics quality to maybe 7 something, or if it's up to 1000. So because I'm using a phone to do this, so you need to understand that the graphics will always be poor, but you can go to YouTube to increase the graphics of this so you can see clearly. So thanks for watching. Please share this to friends, loved ones. Also subscribe if you have not done that, if you enjoy this or you understand this. So thanks again, and see you.